illustrate the law of conservation of energy by discussing the energy changes which occurs when we drag a pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? What happens to the energy eventually? Is it in violation of law of conservation of energy? So we have seen this, right? The potential energy, kinetic energy and mechanical energy for a object that is bouncing. All of this happens in absence of air in an ideal scenario. So what is happening? The potential energy is maximum at the peak and the kinetic energy is minimum. At the bottom, potential energy is 0 and the kinetic energy is maximum. In all of this, the mechanical energy remains constant. Okay, make your observation. Right, guys? A similar pattern occurs when we leave a bob. Okay, so at the peak, the potential energy will be maximum. So at this spot, the potential energy is maximum while the kinetic energy is 0. Here too, at the extreme, the kinetic energy is 0 while the potential energy is maximum. At the bottom, this is the least point. The kinetic energy is maximum while the potential energy is 0. While in between the positions, right, over here, okay, let me use this color, potential energy and kinetic energy both are greater than 0. And here too, potential energy and kinetic energy are both are greater than 0. Okay, agree? Right? So this same pattern has to be explained in detail. That's what they want. They want us to explain this in detail. Okay, the energy transformation, so on and so forth. So when we have to explain such a thing in detail, first thing is the diagram which we just showed. This has to be drawn. I'll explain it later. What has to be written in your exams. Now, first thing is the statement itself. What is that we are discussing about? We're discussing about the law of conservation of energy. So we need to explain what is the law of conservation of energy. Energy can only be converted from one form to another. It can neither be created nor destroyed. And what notation are we using? Well, T and T dash represents the extreme position. B represents the center position. A and A dash represent the intermediate position. Intermediate means in between positions. Okay, all this is good. Now, let me copy this actually. We'll be making use of this. Yeah. So before we release the bob at T, it has the entire energy in the form of potential energy. On release, the energy starts to get converted to kinetic energy as the object starts to move. That is, at A, the sum of kinetic energy and potential energy is mostly constant. At B, the entire potential energy is converted to kinetic energy. Agree? Right? And from B to T dash, as the bomb moves from through A dash to T dash, the kinetic energy is converted to potential energy. Agree? That's how the energy gets converted, and that's why we have this to have a potential energy as maximum and the kinetic energy becomes 0. The process repeats till all the energy is consumed by the surrounding. Okay, so we are talking about this in air. We're not talking about this in our day-to-day, in a vacuum scenario. We're talking about this in air, wherein the energy gets consumed. That's why if you leave a bob, it will go take this pattern and come to a halt. Agree? So this happens because the energy is consumed by the surrounding. Okay, right? So I hope you guys understood the same process, whatever we understood. With this diagram, the same thing has to be explained. Now to answer the remaining part of the question. Why does the bob eventually come to rest? Because the bob comes to rest because the mechanical energy of the bob is consumed by friction, that is the drag force. That is the air basically. Air which has molecules, they get hit and so on and so forth. So there is some kind of friction and so on and so forth, right? Some energy gets transformed and we have the energy getting converted to sound, heat and wind. We can hear some kind of sound if we go very close to the object that is oscillating. Of course, heat and wind, though you guys know, wind is nothing but movement of air. It pushes the air away, right? So does it violate law of conservation of energy? No, it does not violate. The question is, does it violate? You just have to tell no, it does not violate. Reasoning, all of that is explained already, right? The energy is consumed by drag force. Okay, so again all of this has to be written. So you have to start with the diagram. This is not required. The same thing, right? So and we have to talk about the energy.